The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at section 8.5, solving absolute value equations. So let's start off by reviewing the whole idea of absolute value. The absolute value of a number is the distance from that number to 0 on the number line. From 7 to 0 on the number line is 7 units. So the absolute value of 7 is 7. From -7 to 0 on the number line is also 7 units. So the absolute value of -7 is 7. Distance is measured with a positive number or just 0, as in the absolute value of 0 is 0. But distance is not measured with a negative number. So absolute values are either going to be 0 or positive. All right. Now, suppose I had this situation and I said the absolute value of x is 7. What could x be? Well, x could be 7 because the absolute value of 7 is 7, or x could be -7, or we'll say the opposite of 7 because the absolute value of -7 is 7. So x could be what's actually outside the positive number or the opposite of that, because when you take the absolute value of the opposite of 7, you still get +7. Let's see if you got that. Let's say the absolute value of x is 5. Then x could either be 5 or x could equal -5, or the opposite of 5. Do you see that that's true? Any questions about that? Okay. So then what if I have this? The absolute value of x plus 3 equals 5. Well, then either x plus 3 would equal 5 or x plus 3 would equal the opposite of 5, right? Because what's inside that whole quantity has to either be 5 or the opposite, or -5. But now we've got two first degree equations. Let's solve them. We subtract 3 from both sides, we get x is 2. We subtract 3 from both sides, we get x equals -8. Let's see if those are true. If x is 2, we'd have that. If x is -8, we'd have that, which is also true, because then the inside either becomes 5 or the opposite of 5, or -5, which then the absolute value is 5. Are you seeing what's happening there? Well, we'll find out.
Yes.
Okay. What if the absolute value of 2x minus 4 equals 16? That means that what's inside has to either equal 16 or what's inside has to equal the opposite of 16. So that if it ends up equaling -16, the absolute value of -16 still equals 16 on the outside. So to solve the first equation, 2x minus 4 equals 16. Add 4 to both sides of the equation. 2x equals 20. Divide both sides by 2, x equals 10. Second equation, add 4 to both sides. 2x equals -12. Divide by 2, x equals -6. Let's check our work. If x is 10, we'd have the absolute value of 2 times 10 minus 4. which is the absolute value of 20 minus 4, which is the absolute value of 16, which is 16. 16 equals 16, it checks. If x is negative 6, we have the absolute value of 2 times negative 6 minus 4, which is the absolute value of negative 12 minus 4, which is the absolute value of negative 16, which is 16. 16 equals 16, so it checks. We doing okay?
Yes, I'm just writing it down.
All right.
Got it. Thank you.
All righty. What if we've got the following? The absolute value of 2x plus 5 equals 0. Well, that means that either 2x plus 5 equals 0 or 2x plus 5 equals the opposite of 0. But what is the opposite of 0?
Undefined.
No, that's dividing by 0. The
Oh,
opposite
yeah.
of 0 is just 0. It is its own opposite.
Oh, yes.
So basically, when it's equal to 0, we only get one equation.
Yes.
So solving for x, we get x equals negative 5 halves. Subtract, or what, we subtract 5 from both sides. Divide both sides by 2. We get x equals negative 5 halves. Let's check our work. 2's reduced, negative 5 plus 5 is 0. The absolute value of 0 is 0. 0 equals 0. So it checks. All right with that?
Yes.
So if you've got an absolute value equation equal to a positive number, that produces 2's equations, which you go through and solve and then check your work on. If you've got an absolute value equation set equal to 0, you only have one unique equation because 0 and the opposite of 0 lead to the same thing, just 0. Let's take a look at this example. Let's say we've got 4x, the absolute value of 4x plus 9 equals negative 6. So we've got 4x plus 9 equals negative 6, or 4x plus 9 equals the opposite of negative 6, right? Was what's outside or the opposite of what's outside. Let's take the 4x plus 9 equals negative 6. We'll subtract 9 from both sides. 4x equals negative 15. Divide by 4. X equals negative 15 fourths. On the right side, 4x plus 9, the opposite of negative 6 is positive 6. We'll subtract 9 from both sides. 4x equals negative 3. We'll divide both sides by 4. X equals negative 3 fourths. Okay. So we've got two potential solutions. I'm going to pause there for you to get all caught up because I'm going to go to the next page and recopy the problem so that I have room to check the answers. So let me know when you're ready.
I'm ready.
So let's see, 4x plus 9. So 4x plus 9, negative 6, negative 15 fourths, and negative 3 fourths. All right, so let's check negative 15 fourths. 4 times negative 15, oops, fourths plus 9, negative 6. The 4's reduce. Negative 15 plus 9 would be what? Negative 6? What's the absolute value of negative 6? It would be 6. Oh, that doesn't work, does it? Okay, See that?
Mhm.
All right, let's try the other one, the -3/4. 4 is reduced. -3 plus 9 would be 6. The absolute value of 6 is 6. So no solution. Neither one of them worked. Well, let's go back to the original problem. Can an absolute value be negative? Can distance be negative? No. So from the start, we were doomed. An absolute value can't equal a negative number. Now, I went ahead and solved it and got 2 answers, but when I plugged them in, neither one of them worked. Okay. So let's go back. If we've got an absolute value equals a positive number, it leads to two equations. We solve them, we check them. If we have an absolute value equal to 0, we have one equation, we solve it, we check it. If we have an absolute value equal to a negative number, you can go ahead and solve it, but when you check it, none of the solutions are going to work. Okay. All right. Let's see here. Hang on. Put on my glasses. What about this situation? Now, up until now, all the examples that I did, there was an absolute value term equals a number. Now I've got more than just the absolute value term on the left side of the equation. The first thing I want to do before I do anything else is I want to isolate that absolute value term. So my first move here is going to be to subtract 30 from both sides of the equation. Okay. Now I've got an absolute value equals a positive number. So I either have it's equal to what's outside or it's equal to the opposite of what's outside. Solving the first equation, add 10 to both sides. Solving the second equation, add 10 to both sides. Let's check our work. Let's see, if x is 30, minus 10 is 20. The absolute value of 20 is 20. 20 plus 30 equals 50. So that one checks. X is -10. -10 minus 10, absolute value, plus 30 equals 50. -10 minus 10 is -20. The absolute value of -20 is 20. 20 plus 30 equals 50. So it checks. Okay, so in this case, both solutions check. All right with that? How about this one? Now, be careful. You might look at this problem and go, oh, it's equal to a negative number, no solution. Not yet. You have to isolate the absolute value before we make any judgments. Okay. First thing I'm going to do is add 3 to both sides. Oh, it's no longer equal to a negative number, is it? Now it's equal to 0. So maybe there's only one equation, but we're still not done. We'll divide both sides by -10. So now I've got the absolute value of 16x plus 4 equals 0 divided by -10 is still 0. So that's what I'm going to deal with. Okay, so isolate that absolute value term first and foremost. So now I've got 16x plus 4 equals 0. And that's it, because 16x plus 4 equals the opposite of 0. The opposite of 0 is just 0. So the one equation. Subtract 4. Divide by 16. x equals negative 1/4. Let's check it. Negative 10, 16 times negative 1/4 plus 4 minus 3 equals negative 3. 16 over 4 is 4 over 1. 4 times negative 1 is negative 4. Negative 4 plus 4 is 0. The absolute value of 0 is 0. So I've got negative 10 times 0 minus 3 equals negative 3. Negative 10 times 0 is 0. So I've got negative 3 equals negative 3. It checks. But I had to isolate the absolute value first, get rid of any other terms, any coefficients or multipliers out front, and then go from there. All right. What about the scenario where you've got two absolute values? If you've got one absolute value term, isolate it before doing anything else. If you've got two absolute value terms, you want one on each side of the equal sign. Now, what if there's two absolute value terms and some additional terms? We're not going to go there, okay? So if you've got two of them, one on each side, one of them, get it all by itself. All right, now, let's take a look at the possibilities here. There's four of them. We could take what's inside equals what's inside. We could take what's inside equals the opposite of what's inside. We could take the opposite of what's inside equals what's inside. And we could take the opposite of what's inside equals the opposite of what's inside. Okay. But if you look closely, this equation and this equation are really the same thing. If you take that top equation and you multiply both sides by -1, oops, wouldn't you get the bottom equation? So this is a redundant one. Likewise, take a look at these two. If you took this equation and multiplied both sides by -1, you'd get this equation. So this one's redundant. So really, we only have two unique sets of equations. Basically, if we take what's inside the first one equals what's inside the second one, or what's inside the first one equals the opposite of what's inside the second one. And I'm going to do this so I can work on these. I'm going to move this over and say or. Notice I'm taking the opposite of that whole 3x minus 21, not just minus 3x minus 21. Okay, the opposite of the whole thing. All right, so let's solve the equation on the left. We'll subtract 3x from both sides of the equation. X minus 7 equals -21. Add 7, x equals -14. The equation on the right, let's go ahead and distribute the subtraction or the negative sign. So we get -3x plus 21. Then we'll add 3x to both sides and we get 7x minus 7 equals 21. We'll add 7 to both sides. We get 7x equals 28. We'll divide both sides by 7 and we get x equals 4. So I've got -14 and 4 as my two possible solutions. Again, let me know when you're done writing things down. I'm going to recopy this on the next page to check my work.
I'm finished if everybody else is.
Okay, we good to go on?
Yes.
All right, so 4x minus 7. 3x minus 21. we've got for negative 14 and 4. All right, let's try negative 14. Four times negative 14 would be negative 56. Negative 56 minus 7 would be negative 63. The absolute value of negative 63 is 63. 3 times negative 14 would be negative 42. Negative 42 minus 21 is negative 63. The absolute value of negative 63 is 63. So the first one checks. Okay. Let's try x equals 4. 4 times 4 minus 7. 3 times 4 minus 21. 4 times 4 is 16. 16 minus 7 is 9. Absolute value of 9 is 9. 3 times 4 is 12. 12 minus 21 is negative 9. Absolute value of negative 9 is 9. So they both check. All righty. So let's summarize. If you have an absolute value equation with one term that's an absolute value, isolate it completely before doing anything else. If you have two absolute values, put one on each side of the equal sign. Okay. Once you've isolated the single absolute value, if it's set equal to a positive number, it's going to yield two different equations, which you should go through and solve and check. If it's going to be set equal to 0, you're going to get one unique equation, solve it and check. If it's equal to a negative number, you can solve it, but your solutions are not going to work because an absolute value cannot be negative. If you have this situation that we just looked at, where you have an absolute value equals an absolute value, what's inside of one equals what's inside of the other, or what's inside of one equals the opposite of what's inside of the other. Those two equations, solve them, check your work. Always check your work on these, okay? Any questions at this point?
No.
All righty, let me do one more.
Okay.
Let's do this, 3x plus 7 and 3x minus 4. All right, so we've got the case where we have two absolute values, they're already separated. So one equation is going to be 3x plus 7 equals 3x minus 4. The other one is going to be 3x plus 7 equals the opposite of 3x minus 4. Okay? Solving the first equation, we'll subtract 3x from both sides and we get 7 equals negative 4. That's a contradiction, so that doesn't lead to a solution. Let's take the other equation. Let's see here. We'll distribute the negative sign, so negative 3x plus 4. We'll add 3x to both sides. 6x plus 7 equals 4. Subtract 7 from both sides. 6x equals negative 3. Divide by 6, x equals negative 1/2. Now let's check our work. Negative 1/2. Let's see, we've got 3 times negative 1/2 plus 7. 3 times negative 1/2 minus 4. 3 times negative 1/2 would be negative 3/2 plus 7. And this would be negative 3/2 minus 4. Well, let's see. 7 over 1 times 2 over 2. We've got negative 3/2 plus 14/2, which would be what, 11/2? All of this, absolute value. And on the right side, let's see, we're going to multiply that by 2 over 2, and we're going to have negative 3/2 minus 8/2, which would be negative 11/2. Well, the absolute value of 11 halves is 11 halves, and the absolute value of negative 11 halves is 11 halves. So here we get two potential solutions. One doesn't work, one does work. Okay, or I should say two potential equations. We didn't get a solution here. So it's possible to come up with two equations, but only one of them works and one of them doesn't. So be careful of that. Okay. All righty. That's it for today. I'll be back at 1:15 this afternoon with an office hour. Should you have need of me, I'll stop the recording